Welcome to our NPTEL lectures on the power quality improvement technique. We shall continue with the general basic reviews. So, we continue with we have discussed about the sag, swell and other THD interharmonic. Now, we are going to discuss the noise. Though it is not, it is a very much problematic for the signals, because SNR ratio is a very important quantity, but we also have a problem of noise in case of power quality issues. So, for this reason, if noise comes with the modulating waveform or the carrier waveform, then essentially you get a distorted voltage and current in the output. So, we have to require to eliminate the noise also. So, noise, it may be a very low power entity into the power engineering, but it may cause a serious disturbance into the system. So, noise is defined as a unwanted electrical signal with the broadband spectral content lower than 200 kilohertz. Since because of the high frequency, its amplitude is quite low, but it may contaminate the system very well. Superimposed upon the power system voltage and current in phase of conductor or found in the neutral conductor and lines. Sources, definitely the main culprit is a power electronic device, and source is mainly the control circuit of this entity. And if the control circuit contains the noise, it is essentially, inverter is essentially an amplifier. So, whatever the control circuit you give, so modulating signal, it amplifies. So, thus what happen, if you have a noise into the control circuit, this will be amplified by the power electronics devices. Definitely source will be the control circuit, others are arcing equipments, loads with the solid state rectifier and switching mode power supply or SMPS or switching power supplies. Now, let us define that voltage fluctuation. Please note that this is a different from the sag and swell. So, we have a different condition for the fluctuations. The voltage fluctuations are systematic variation of the voltage envelope within some range, smaller range envelope or series of random voltage changes, the magnitude of which does not normally exceed the voltage range specified by ANSI C 84.1, and generally this range is restricted to 0.9 to 1.1. So, this is the range which once it is having, then we will say that voltage fluctuation, neither sag or swell. So, for this reason sag is 0.9 to 1 and swell is also 1.1 to 1.8. Within that, if you have a variation, then we say that it is a voltage fluctuations. Of course, the source of these fluctuations are loads that can exhibit continuous rapid variation of the load current magnitude. It happens in a highly accelerated machine in case of the adjustable speed drive can cause a voltage variation that is reversed as a flickers also. So, this is the case, the waveform, we have taken this waveform for voltage fluctuation caused by the arc furnace operation. So, you can see that voltage fluctuates and this fluctuation voltage is within this 0.9 to 1.1 range. This is the arc furnace operation. Now, this is the power frequency variations are defined as a deviation of the power spectrum fundamental frequency from the specified nominal value. So, this is the a minimum frequency, this is a maximum frequency and this is average frequency. So, we have considered a US system. So, there is a 60 hertz variations. There you can see that you can have a maximum frequency variation up to 60.05 to 49.5. So, once it is little light load, it can have that value 60.05. Once it is highly loaded, it will come down to here, and this is a hour wise data. This is 4 to 8, 8 to 12, 8 and the 24 hours whole day data. This is a variation of the frequency daily, and this is the frequency of this. You can see that time tag data, that is a sample is 286 and minimum frequency has been noted, it is 59.95, average is of course 60, that is what in USA single USA frequency, and maximum is this thing, and this is the time tag data of various entity, and this is a way it varies. So, power frequency trend in a statistical distribution in the 13 kV substation, mind it, they have a, they do not have, we have a multiple of 11. So, they have a little different 3 kV substation bus and courtesy to this company. So, we define something, this is the peak value, we know it very well, this is the current and voltage, and this value is RMS value, that is 7.707, and this is average value, that is 0.63, and the ratio is called form factor. So, thus RMS value is quite 707 into peak value, and the RMS value equal to 1.1 into average value, and the crest value is the peak by RMS is 1.414, that you know quite well. So, based on that, those calculation required to be done. Now, the computer manufacturer, now most of the power problems comes from the power quality problem comes from the computer manufacturer, and that is something we require to see. For this reason, we have a CBMA curve. So, it is essentially that computer manufacturer company, they get into a system and design a power quality issues, because ultimately computers manufacturers were blamed for deteriorating power quality by the utility, and also there is a blame game started, and to protect themselves they then come out a standard and say that you require to maintain this kind of power quality for these devices, otherwise this sensitive equipment like computer will not operate. There is a whole battle between the GE and the IBM. The set of the curve representing the withstanding capabilities of the computer in terms of the magnitude and the durations of the voltage disturbance, and this is developed by Computer Business Equipment Manufacturer Association, predominantly led by the IBM. So, this is the CBEMA. Now, you can see that this is a percentage of the voltage, and this is the computer voltage tolerance envelope, and a portion of the CBMA curve is normally used for design the target equipment and a format for reporting power quality variation data. So, this is a computer tolerance graph, this is the 100%, and for the small time this is the cycles in seconds. So, for the 1 cycles you can have this much of high voltage, and you can have also this kind of low current, and gradually it will match. So, you have to maintain around 87% of the voltage or 6% high voltage for the manufacturing of these computer devices. So, this is kind of data is been given to the utility, and you require to maintain, the utility required to maintain this amount of the voltage precision in the output. So, that is what let us describe. The axis represents the magnitude during the event. The points below the envelope are presumed to be cause load dropout or the lack of energy. The point above the envelope represents the cause of malfunction such as insulation failure and the over voltage and the over tip execution. So, now thereafter this ICBMA curve has been little modified. So, it is now the computer manufacturers all over the world follows this ITI curve. It is set of the curve published by the information technology industry, just they changed the name from the computer to the information technology industry council, that is ITIC, representing the withstanding capabilities of the computers connected to the, they are having a 112 volt systems in terms of the magnitude and distortion of the voltage disturbance. The ITI curve replaces the curves originally developed by ITI's predecessors, this organization. So, this is something quite elaborate curve. So, for this is for the cycles, for you can have 5 times more 5 per unit voltage for a very small amount of time, that is for the 0.1 cycles. Then within 1 millisecond it has to be brought down to 200%, then in the 3 millisecond we have to brought to the same value. Same way, if there is a sag, then after within a 20 millisecond you have to bring this voltage to 70 millisecond. Thereafter after a point in 0.5 second you have to bring it to the 80%, 90% and so on, and close to 90% voltage. For the higher voltage tolerance also it is 105 volt, and for lower voltage also 105% and 95% is a steady state value. So, this is the ITI curve that the Computer Manufacturers Association follows, and once you supply it, if you have if your computer has been damaged, then you want that then of course, if they will get an escape route if this voltage criteria was not fulfilled, and they will pass on the buck to the utility. So, you have to ensure that this kind of power quality has been maintained by the utility system while feeding a computer load. Now, let us come to the real problem. We are discussing the different kind of mode of operations and other issues. Now, we will talk about the PQ problem, that is the reactive real power and the reactive power problem. The major source of the power quality problem can be divided into the two categories depending on the locations and the source in relationship to the power meter. One, utility side meter includes switching operations, you change over the isolators, power system faults, lightning, and other categories are mainly for the user ends. That includes the nonlinear load, poor grounding. So, there is an oscillation of the neutral point that leads to the also some kind of problem in case of the power quality, electromagnetic interference and the static electricity. So, these are the another category that causes the problem mainly in the PQ. So, let us see in a utility side of the meter, that is sometimes called also statistical metering. Source of the PQ problem on utility side of the meter involves some time of activity on utility electrical power system, They can be either man made or the natural event like lightning strikes and all those things, they all involve some type of interruptions of the current and voltage. The amount of the common man-made causes are switching operations. Utilities switch equipments on and off by use of the circuit breakers, disconnects of switches or the recloser. These are the activity. Usually some time of fault on the power system caused a breaker to trip. For example, we have taken so many example of the so many example of this single line to ground fault. Utility trip breakers to perform routine maintenance. They also trip breakers to insert capacitance to improve the power factor. So, that is something it is quite important. Utility side of the meter. Now, lightning strike of a power line or the distribution systems are definitely some of the natural causes. A tree touching the power line and a car hitting the power pole or even an animal touching the energized line may cause the fault. So, these are the causes. The tripping of the breakers and the initiating a fault can cause voltage sag in one line and thus voltage swell in another line depending on when the periodic wave tripping occurs. The utilities sets the breakers and reclosers on the fault to determine if the fault has been cleared. If fault has not cleared, the breaker or the reclosers trips again and stay on. So, let us see that the utility circuit breaker, you are well known. This is this is a picture of the utility circuit breaker and unity power factor improvement capacitor. So, these are the entities. Once you switch on or switch off, there has to be a transient and that cause a power quality problem into a system. It can be sag, swell or sustained oscillation, fluctuations, anything. Now, let us come to the role of the utility side of the meter. Utility activity can be caused oscillatory transient, that is what I am saying, in the switching of the power factor improvement capacitors. Mainly we have discussed in a separate class that issues of the capacitor. Utilities use power factor improvement capacitor to improve the power factor by adding capacitive reactance to the power system, since predominantly we have the inductive power system. This causes the current and voltage to be in phase, thus reduces the loss in the power system. When utilities insert capacitor in power system, they momentarily causes increase in the voltage and causes transient. Capacitor, if tuned, the harmonics power capacitors, if tuned on harmonics on the power system, they can also amplify the harmonics. That is also a problem. So, this is a problem that we discussed detailed in case of the passive filters. Why active filter is preferred over the passive filter? There we will dedicate a whole lectures on the designing of the passive filter. One of the major disadvantage of the passive filter is that if it is tuned to the particular harmonic, it may cause a resonance, and resonance may cause, with the leakage inductance of the capacitor and this capacitor bank, and that sets up the resonance, and it aggravated by the presence of that particular harmonic which you want to attenuate. This is especially true for utility end user, both switching their capacitor at the same time. So, that is the challenge here, and we require to damp out the oscillation. That is also a biggest challenge of the power quality. And the end user size of the meter, what does it do? Sources of the PQ problem, on the other hand, the end users side of the meter usually involve a distortion or disruption of the sinusoidal voltage and current delivered by the end user utility. This disruption can damage or cause misinterpretation of the sensitive electronic equipments in not only the end user facilities and but also the end users facilities that electrically connected. So, following is the list of the power quality problem that is generally caused by the end users or the consumers. The nonlinear, mostly for the industrials, not the common man, the nonlinear inrush current from startup of the large motor, static electricity, power factor improvement capacitor amplifying the harmonics, and poor wiring and the grounding. Poor wiring may lead to the increase in inductance. So, you have to show that you have to put the wiring such a way the antiparallel current flows and your inductance get minimized. It destroys the, it mitigates the flux, but and same way for the grounding, if it is not properly grounded, the neutral point will oscillate. That also leads to the power quality problem. Moreover, so the nastiest entity is the nonlinear load. There are today many types of nonlinear loads. All these devices changes the smooth sinusoidal wave from the irregular distorted wave shape. We have seen a waveform for the input waveform for the adjustable speed drive. This distorted wave shape produces harmonics. They include all type of electronic equipments, and these are SMPS, switch mode power supply, ASDs, that is adjustable speed drive, rectifier, inverter, arc welder and the arc furnace, electronic and the magnetic ballast that used for the fluorescent light, medical equipments like MRI, magnetic radiation image and the X-ray machines, other devices that convert AC to DC and generate harmonic include battery charger, UPS, electron beam furnace and induction furnace. So, list is very big, I just capture few of them. So, all are comes under the category of the nonlinear load. So, we require to see that how we can mitigate those. So, most of the electronic devices use switch mode power supply to produce harmonic. So, essentially it can be mainly it is rectification thereafter DC to DC converter, and it will produce lot of harmonics into the system. The manufacturers of the electronic equipment have found that they can eliminate a filter, they can eliminate the power supply transformer, and we will show in the next figure by use of the switch mode power supply. And so, let us see that what is the switch mode power supply and how does it produce harmonics. The switch mode power supply switch mode produces in the switch mode process converter AC to DC using a rectifier bridge, converter converts DC back to AC at high frequency using a switch stepped the AC voltage down to the value of the step down to the DC voltage for the Mons transformer. So, this is the case of this power supply issues. So, this is the normal rectifications, and thereafter you will have a ripple DC here, you are almost after filter you have a constant DC here, and since it required a bulky transformer, we try to get rid of this 50 hertz transformer. Instead of that, we wanted to have a SMPS here, and then what happened, you got a so this is the normal rectification there we generally use in case of our project work, that it is a 220 volt to the 18 volt supply, something like that. Instead of, we prefer SMPS. We rectified, and ultimately this is a 310 volt for India, because it will be almost driven to the peak value of it, not that average value if it is not loaded. Then you have the switching regulator, that can be a high frequency DC to DC converter. Since it is a high frequency, so entity will be the compact. So, that is what has been described in the lectures. So, rectifier diode, it can be thyristors or diode depending on the controlled rectification or not, and this is the power supply, and it has been reprinted by this magazine, anyway courtesy to them. So, this uses the SMPS, and finally, what does it do? It converts AC to DC using another rectifier. The electrical equipment requires a 5 volt DC to operate. So, your all the nowadays we have a different kind of voltage in your USB. So, once you charge your mobile from your computer USB, it gives you the 5 volt. So, how does it generate? It generate from this way. So, if you go inside the switch mode power supply, and you will find a switching circuit takes stored energy from the capacitor in a short pulse and delivers the voltage at a frequency of as high as 20 kilohertz to 100 kilohertz to a transformer to form a square wave. So, that require a high frequency transformer. This high frequency switching requires small and light transformer, that is the advantage of it. So, you got a compact. So, for this reason nowadays all your laptop charger, all your mobile charger are of this entity. However, this pulse square wave distorts the sine wave and produce the harmonics. So, try to see with if possible in your lab, you have to maybe destroy your laptop charger. So, just just try to see that what kind of current you are taking once you operate your laptop. So, you will find that lot of distortion into it due to the SMPS. And another element, these are adjustable speed drive, saves energy by adjusting speed of the motor to fit the load. Generally, it is a V/F control or the vector control. So, it can generate a variable speed, and you may require a constant torque, for this example hoisting. Then it is a perfect match, but essentially we have a constant frequency supply. So, first we may have a direct matrix converter also, but instead of that, if you convert to intermediate DC AC DC AC conversion, then what happen? However, in adjustable speed machines drives causes harmonic by varying the fundamental frequency in order to vary the speed of the device. Same way, the arc furnace uses extreme heat around 3000 Fahrenheit to melt metal. The furnace uses an electrical arc striking from the high voltage electrode to grounded metal to create this extreme heat, and there also sometime current flow, it does not. So, intermittent current causes a lot of problem. This arc is extinguished Again that is one of the problems, this is a discontinuous in nature. In every half cycle, the short circuit ground causes the voltage to dip each time once it strike the arc. So, voltage develop falls, voltage develop falls. So, fluctuating current voltage which we have seen is due to the arc furnace, and this cause the lights to flickers at a frequency typically less than 50 or 60 hertz, 50 hertz in India, that is irritating to the human. Mostly this is called the stroboscopic effect in case of the and the flickers, and this will generally harm the productions also in a company. An arc furnace also generate harmonic current, and that required to be mitigated by some means. Thank you for your attention. We shall continue to our discussions, and we had left with another few chapter to give you the overview of the or the scope of the power quality in our next class.